All right, everybody, let's continue. Let's move on to page 184, which is section 2-3. I'm going to do some questions from there. So we're going to start with number, so this is page 184, problem number 35. Sorry, I'm getting a little tired here. All right, so they have given you an equation in problem number 35. This is 3x plus 4y minus 12 equals to 0. I miss seeing students in class and just talking and being engaged in class. This whole situation sucks, but what can we say? But anyways, problem number 35. It says write each equation in slope-intercept form. Then identify the slope and the y-intercept. So notice slope-intercept form is y equals mx plus b. That means I got to solve for y. So you want to move everything that doesn't have a y to the other side. So I'm going to start with 3x. So I'm going to subtract 3x. So I'm going to get 4y minus 12 equals to negative 3x. Then I'm going to add 12 to both sides. So 4y equals negative 3x plus 12. And then finally, since 4 is being multiplied by y, I'm going to do the opposite operation. You divide, and voila, you're done. Y equals to negative 3/4 of x plus 12 divided by 4 is 3. There you go. That's the equation slope-intercept form. What is my slope? My slope is negative 3/4. What is my y-intercept? It's 0, 3. Because x for y-intercept is always 0. If I were to graph this equation, I would get a line that would be falling. Why? Because the slope is negative. All right, so that was number 35. Now let's jump to number 60. Let's see. I'm sorry, I lost it for a second. It says, find the equation of a line using the information given, write the answers in slope-intercept form. Okay, before we go any further, I would like to remind you about this handout that I uploaded last week. It's a good visual and a flow chart that one of my colleagues made a long time ago, and about writing equations of lines. So you just follow. If you have given this, if you have been given the point and a slope, you just plug them in, and you just go down into one of these and then write the equation. If you're given 2 points, then the first thing you want to do is find the slope, and then once you have the slope, then you pick one of these points given. It doesn't matter which one. And you plug it in here or in here to get the equation. If you have a point and the lines are parallel, then you have the slope from one of the equation of the lines, and so you use the same slope because lines are parallel and the point, and you plug it in. And if the lines are perpendicular, then if you know one of the slopes, then you just get the negative reciprocal and follow. So I just want to point out that you can use this flowchart as a resource. All right, so number 60, yes. We have 2 lines that are parallel to each other. So this is number 60. We have 2 lines, line 1 and line 2, they're parallel to each other. And okay, so line 1 is, we have the equation, and line 2, we have the y-intercept. And we want to find the equation of line 2. Okay, so we know the lines are parallel. So in order to find the equation of the line for line 2, we need the slope. But I don't have the slope, but I can get the slope from here. Because the lines are parallel, the slopes will be exactly the same. So if I solve this equation for y, then I know the slope. So subtract 6x, so you get 9y equals negative 6x plus 27. Divide by 9. y equals to, this is divisible by 3, so negative 2/3 of x plus 27 over 9 is 3. So what's the slope of line 1? Negative 2/3. That means the slope of line 2 is also negative 2/3 because the lines are parallel. Okay, now I want to find the equation of that line. I have a point, I have a slope. I go straight down to this box, and I'm going to choose the point slope form because we haven't used it. So I'm going to plug everything here. So point slope form is this. So I have the slope, voila, goes right there. And the point that's given to you, you put it right here and here. So the y value is negative 7. I'm going to put it right there. So y minus negative 7 equals to slope negative 2/3 x minus 0, because that's my x value. Okay, x minus 0 is just x. So on the right side, I get negative 2/3 of x. I can just forget about that. Y times y. I'm sorry, negative times a negative is a positive. So what's my last step? Subtract the 7. And voila, I get my equation. So this is the equation of the second line. As you can see, the slopes are the same. Okay, all right, very good. Next problem is 61. Problem 61, very similar. This time, two lines are given to you, line 1, but they're perpendicular to each other. It's perpendicular to line 2. And we have the equation of the first line, and we have a point on the second line, and we want to find the equation of that line. Okay, so same thing again. If I know the slope of this line, I can know the slope of this line because the lines are perpendicular. So let's solve for y. So I'm going to add 3x to both sides. So I get 5y equals 3x plus 9. Then I'm going to divide by 5. Nothing can be reduced. So I get this. So what's my slope of line 1? M1 is 3/5. Lines are perpendicular. That means M2 is opposite sign of this. So if this is positive, that will be negative. You flip it over. It's 5/3. Okay. Now, I don't have, this is not the y-intercept. Why is it not the y-intercept? Because the x value is not 0. So this time, I want to use, okay, so I have a point, and I have a slope. I'm going to go straight down here. I used the point slope form last time. I'm going to use this, the slope intercept form, because you can use it to get the equation of the line. So y equals mx plus b. So your m is negative 5/3. Your x value of that point is 6. I don't know what the y-intercept is, but I know what the y value of that point is. There you go. Okay, so this is 6/1. So I'm going to solve for b. 3 goes into 6 twice. So negative 3. Negative 5 times 2 is negative 10. And I'm going to add 10 to both sides. So I'm going to get 7 equals b. So my y-intercept is 7. So what's the equation of the second line? Y equals negative 5/3 of x plus my b, 7. There you go. So that's the equation of the second line. I hope I don't go too fast. All right. And there's a word problem that I would like to... well, let's try the word problem. The word problem is page page 186, number 103. It's rather long. Page 186, 103. It says, according to internet worldstats.com, there were approximately 143 million internet users in 2001. By 2008, this figure had grown to nearly 220 million. Part A, assuming the relationship is linear, use the relation year internet users with t equals 1 corresponding to find the equation model for the number of users. each year. You know what? I'm gonna do this on Tuesday. So let's do that on Tuesday. So let's move on, because I want everybody to get their books. Hopefully they have it on Tuesday. Hopefully you guys all have it on Tuesday. All right, so let's move on to the new section. Let me make a note. Okay, so the next section we're going to deal with is section 2-4, which is on functions. Sorry. Now let's talk about functions. Functions are defined as relations where domain values domain or input values do not repeat. Okay, well, first of all, what is a relation? Is a relation, not relations, sorry. A relation where domain values do not. Okay, what is a relation? It can be defined in many different ways, but so a relation could be ordering, pairing of numbers. So for example, I can say a set A, 0 and 2, 4 and 5, and -1 and 3. Here's a relation. We have ordering of, I'm sorry, I keep saying ordering, pairing of numbers. Okay, it's made up of these 3 points. Now, let's take a look. Is this relation a function? Well, look at the domain values. Now, the domain values are your input values. That means your x values, what goes into the function. We call these numbers, the y values, the range. So domain and the range. I'm sure you guys have seen this very crude picture in middle school where you have a function machine. Something goes in, we call it domain or input or independent value. Something happens in the machine, and what comes out, we call it range or output or dependent value. Okay, so my x values, I'm usually called the domain x, the range y, usually, not always. So my x values are the domain, my y values are the range. So a relation, a function is a relation where domain values do not repeat. So look at the domain values, 0, 4, -3. Are they repeating? Are they the same? No, they're all 3 different numbers. So this relation is also a function. But let's say I had 0 here, then these 2 domain values are repeating, then this relation is not a function. So every function is a relation, but not every relation is a function. Let me show it to you with another diagram. So functions are subsets of relations. So every function is a relation, but not every relation is a function. Okay, so that's one way of determining whether a relation is a function or not. And another way is if you have a graph, we have vertical line test. What is a vertical line test? Let me define it first. So a vertical line test is to check if a graph represents a function or fonction. If you want to impress your friends at the next party, always speak French or Spanish. Fonction. Okay, all right. So let's say I give you a graph that looks like this. It's an absolute value graph, don't worry about it. How do we know this graph represents a function? So you perform a vertical line test. That means you draw a vertical line anywhere on the graph. Now, if I draw the line over here, how many times does it intersect the graph? Once. If I draw it over here, boom, how many times does it intersect the graph? Again, once. If I draw it over here, boom, once. So if your vertical line intersects your graph only once, then your graph is a function. So this is a function, or represents a function. Because look at it, this point, whatever it is, has an x value that's here. This point has an x value here. This point has an x value here. Are these x values repeating? No, they're all different numbers. Therefore, the domain values are not repeating. You do have this graph represents a function. On the other hand, if I give you a graph, that's a circle. Say like this. Well, it looks like a potato, but imagine it's a circle. If I draw a vertical line here or here, what happens? Look at it. It intersects the graph here and here. It intersects more than once, correct? So, does it represent a function? No, it does not. Not a function. Why? Because, let's say this point here, I'm just making this up. Let's say this is -2 and this is 4. So this point here is -2, 4. And let's say 1, 2, 3, 4, 5. And this point here is -2, -5. Notice the x values, the domain values, they're exactly the same. That means they're repeating. So a function cannot have a repeating domain value. Since these guys are repeating, therefore it's not a function. So if you're performing a vertical line test and it intersects more, and the vertical line intersects your graph more than once, then it's not a function. Then the graph does not represent a function. Okay. All right. And as far as functions are concerned, we have special notations for it. You probably have seen it like f of x or g of x or h of x and so forth. What they all means y. It's just a different way of writing it. Okay, so if I say y equals to 3x minus 2, I can write it as f of x equals to 3x minus 2. What does that mean? That means a function in terms of x. The function itself is called the f function, but this is your y value, a function in terms of x. And your x is your domain, it's your input, what goes into the function, and your y, or this, is the output. I'll give you a quick example. Let's say I say f of 2. What does that mean? That means your input, your domain is 2. And what comes out? 6 minus 2, 4. So that means domain is 2, the range is 4. I can also write it as a point, 2, 4. Independent value was 2, dependent value was 4. Okay, so let's do a couple of quick examples. On page 197, take a look at problem number, on page 199, take a look at problem number 40. And if you look at number 40, you want to see if that relation is a function. If you do a vertical line test, you will see that it will intersect only once. So it is a function. And if you look at 43, it's an oval shaped or an ellipse. And it's just like a circle. If I do a vertical line test, it will intersect more than once. So the graph in 43 does not represent a function. And then the next problem I was going to do was a word problem. Okay, it's on page 200, problem number 97. Page 200, problem number 97. Let's see if I can put it underneath here. If I can. My whole setup will be messed up here. But, nah, never mind, I can't. Okay. So I'm just going to read it for you. So, page 200, problem 97. It says, Jackie has a gas-powered model boat with 5-ounce gas tank. the boat will run for 2.5 minutes on each ounce. So 2.5 minutes on each ounce, okay, of gas. Okay. All right, now then the number of minutes she can operate the boat is a function of how much gas is in the tank. Well, that's obvious. The more gas you have in the tank, the more time you can spend, operating the boat. So part A, it says, write this relationship in function form. Okay, so I can use whatever, G of, well, let's define our variables first. G is not a good one. So let's call it G representing amount of gas. So let's say F of G, right, would be 2.5 times G. So G is the amount of gas. That's the independent value. The more gas, the more operation time. Less gas, less operation time. So that's one way of writing as a function. And then part B, it says write this relationship. Oh, I'm sorry. It says determine the domain and the range of the function. Okay. Well, the domain, what's your domain? Domain are all your input values, right? So remember, it says Jackie has a gas-powered model boat with 5-ounce gas tank. Can you fill it with more than 5 ounces of gas? No. So your domain is from 0. I'm going to put brackets here because 0 can be a number for the domain, all the way to 5. So that's my domain. And the range will be the time that you can spend using this. So if you have 0 amount of gas, you have 0 amount of time. But what's the maximum amount of time you can use the boat? So if I fill the tank completely, that is 5 ounces, so 5 times 2.5, that's 12.5 minutes. That's the range. We define the domain and the range. Okay. Last section, ladies and gentlemen. Let's do this. Last section is pretty quick. So section 2-6. We're skipping section 2-5. It's basically it's correlation of linear function and real data. So I'm just going to show you a couple of examples. Let's see if I can show you. I think I can show you this. You see this? You see this one? This graph, these 3 graphs of real data. So for example, the first one is the value of an auto by the age of auto. As we all know, as time passes by, what happens to the value of a car? It depreciates. So this, and can I fit a straight line through these points? I mean, I will not hit all the lines, but I will hit most of them, right? So this represents a linear relationship where the correlation is negative, or it has a negative correlation because it has a negative slope, it's going down. Take a look at this one. Oh, sorry, the middle one. This is all over the place. I mean, I can put a line, kind of, but it's not gonna be close to a lot of points. Okay, so this does not represent a linear relationship. Well, kind of. And I would say it has a weak positive correlation. Okay, very weak positive correlation. This one had a very strong negative correlation between the two, the value of a car and the age of the car. This one, it has a positive correlation because I can fit a straight line going this way, and it's better than the previous one. Kind of a positive correlation, and I would say it's a linear relationship between male heights and male weights. Okay, if you look at this example, for example, in this example we plotted these points, high school GPA as the independent value or the horizontal value, and college GPA. And notice it has a very strong positive correlation. The better your GPA in high school, better your GPA in college. That means you're a better student, usually. Okay? All right, so look at this problem. We have the another table of values. We plot it, has a very strong negative relation. You can also calculate the slope of a line like this by just picking 2 points on the line. Let's say if I want to calculate this, I can pick either this point or this point and this point. You have an x value and a y value, x1 and y value, and you can calculate the slope. And same thing over here. You can calculate the slope in the previous example. You can pick a point here and maybe a point there. It's not going to be very accurate, but it will be close. So, but you know that the slope will be positive because it has a positive correlation. This one, you know the slope will be negative because it has a negative correlation. Okay. And then there are some examples on this page, page 232. Very strong negative correlation, relatively negative correlation, relatively strong. No correlation, is not a linear relationship at all. Weak linear relationship, weak positive correlation, very strong positive correlation, and a linear relationship. And that's it. That's all I wanted to talk about. Okay, and these are called scatter plots, by the way. They're called scatter plots, where you plot individual points. Okay, so that's it, ladies and gentlemen. We are done with chapter 2. I hope I didn't put you to sleep by my talking, and see you and talk to you on Tuesday. Take care. Bye.